everyone, welcome back to my channel, and today we will together solve the daily LeetCode problem, which is the new 21 game. So this is the dynamic programming problems, and yeah, so we will solve it together by breaking it down and make it become very easy to understand. Yeah, because like the examples in here, I think that they are useless, so that's why I take another example. For example, like in here we have the k equal to 4, n equal to 6, and the max point is equal to 3. Yeah, so to solve this problem, so it means that like we need to find the probability and just breaking down it by using some kind of probability. And let's say that we always start from the 0 point. And yeah, so let's say that our current state, that is a 0 in here. And so for example, for the first state, we will want to jump from 0 to 1. So it means that like the p from p1, right? We have the p1 equal to what? P1 equal to p1 given 0 by the p of 0. So this one is like, because like the p0, or we always start from like 0. So it means that this probability is equal to 1. So in here we have three choices because of the max point. And for every single step, and then we can have like three choices. We can choose like the 1, 2, or 3. We draw one number from this set, and then like the most important thing is that like the probability for the each outcome is equal. And then so it means that this one is what? This one is like 1 over the max points, right? So this one is equal to 1 over 3 by 1, so that is the 1 over 3. Okay, so how about if we have the 0 and then 1, and then we evolve to the 2, and then how many choices we have in this case? So we have two choices. We draw 2 from here, or we can draw 1 from here, right? So what does this mean? This means that the p of 2, that is equal to the p of 1, p2 given 0 by the p0, right? Plus the p of 2 given 1 and by the p of 1, right? However, we have the observation in here. This one is equal, because like we have already know that like the probability for us to draw 2 is which is equal to the probability which is from 1 and we draw 2, right? We draw 1, right? So this one is 1 over the max point, right? Plus 1 over the max point in here, and then in here we have the p1, and then we have the p0 from here. So what does this mean? It means that we can put it down, we can group it at the 1 over the max point, and then we get the p0 plus the p1, right? So you can see that in here somehow like we maybe have some kind of the relation between the stage, right? And then so how can we do this? Yeah, so let's do maybe 2 more example. So p3, so we can demonstrate that this one will be equal to 1 over the max points, and then that would be like the p0 plus p1 and we plus p2 in here. Okay, so that is like we have the 0 in here, we have the 1 in here, we have the 2, and we have 3. So it means that we can transition, we can move from 0 to 3, 2 to 3, and then we also can move from 1 to 3, right? And because they are like the conditional probability, like they are equal, like this one, so we can group it together. So how what if like we have the 4? So that is the special case for us. And here, for example, 3, and we have 4 in here. So because like our maximum value, we can jump, that is just like the maximum point in here, that is just 3. So it means that we cannot move directly from 0 to 4. We cannot do this, right? We cannot do this. The only one thing we can do is that like we can just move from 3 to 4, 2 to 4, and the 1 to 4. So what does this mean? This means that our p4 that is equal to 1 over max points, and then that would be like p1 p2 and plus the p3. So we can see that in here somehow that is exactly the things like the sliding window with the size is the window size equal to the max points, right? Okay, so it means that in here like we exclude this point out of the window and we add the new point, which is the previous stage, right? Previous probability. So for now we can see the recurrent relation. Okay, so with these observations we can program this problem together. We will initialize the array for that. So for example, like in this case, for example, like we initialize the DP array, which is equal to the 0, and then because like we will have the n plus 1 element because we start from 0, right? And the largest number we can reach is like we just expect to reach to the end, and then it means that we need n plus 1 element starting from 0. And so in here, because like for our case, and then we always have the dp0, the probability of the dp0, which is always the 1, right? And then so for the previous probability, and then we will assign it equal to 1 as the initial. If the k greater than 0, else we will return, we will just put it as 0. Yeah, because like in here like we only continue drawing the new number if that number is like smaller than k, otherwise we will stop it directly. Yeah, so for now we will get the I in range of 1 and n plus 1, right? So this is our current stage, and then for this current stage, and then we can see that like the probability is always equal to the previous probability divided to the max point. So this simulate this formula, it simulate this number, yeah, this formula. Okay, so in here we have already got the probability in this stage. For example, like we are in here, and then we are getting the P3, for example. Let's say that we are in the 3, right? We have the P3. Okay, so in here, like if the I is smaller than the and in the K, it means that like we can perform the future step by drawing the new number. So it means that like this is the transition, like we want to get the probability transition from probability from here to here, right? So it means that like we want to construct this thing and then pass this in the next iteration, right? Yes. So yeah, so here like for example, in this case we have the s plus equal to, so this one is the previous probability. We will update this, that is equal to the dp of I, right? And what if the what if like we reach into these conditions? For example, like if in here like we have the maximum of 3, however, like what if the current stage minus the maximum point equal to 0? So it means that we are in the 3 in here, right? And then like in the future, at this step, like we will have the plus 3, for example. However, like in here we need to exclude the 0 in here because like the current step and then minus the maximum point that is equal to 0, so we need to exclude this one in the future. Yeah, so by doing so we need to check the conditions of the max point, that is like greater or equal than 0, and di minus max point that is like smaller than k, right? It means that we can perform the future step, and then like the previous probability, and then we will minus this to the dp of the I minus max point. Okay, so in here, so because we just cared about the p, because we cared about the p of what, p of like the number which is the I greater than k and smaller or equal than n, right? So in here like that is the summation of the probability from the k, right? Okay, so let's do this. Max points, maybe something here. Typos error. Oh yeah, typos error. Okay. Okay, so I think most of the people have the same solution as me. So I think that I hope that this one will help can visualize and help you to understand the procedure and feel that dynamic programming is not too difficult. But yes, the recurrent relation in here is the most important thing. But yeah, so that is the trick. The trick is like we always looking for the things for the trick. But the thing in here, the trick is that like we can put the max 1 over the max points out, and then this is the probability accumulated over the iteration, and then this helps us to have the efficient calculation and using the sliding window as well. Yeah, so thank you so much for watching my video, and if you like and if you want to give me more motivations in the future to do more videos for you guys, please give me a subscribe or comments. Yeah, again, thank you so much for watching my video, and see you next time.